Hello! We're learning about absolute value inequalities today. Now here's the thing, if you don't remember how to solve absolute value equations, go ahead, take a second, watch a video about that before you try to do this. Because if you can't solve an absolute value equation, then an absolute value inequality is not going to happen for you. The highlights, just to keep those in mind, is that to solve an absolute value, we have to remember that it's the distance from 0, and it will always be positive. So, for example, the absolute value of 9 is 9. Take it, make it positive. The absolute value of negative 9 is 9. You take it, you make it positive. So therefore, when we have an absolute value equation, we always expect two answers. Every absolute value inequality becomes a compound inequality because of this principle. I think it's helpful to take a second just to remind ourselves how to graph an inequality. So let's just go ahead and do that really quick. So we start at 0. We can go up to 4. We're looking for numbers bigger than 4. Notice we have a greater than or equal to sign there. So that means we shade this side of the line, and we will fill in the dot because we have the or equal to underneath. Similarly, we can do the same thing for this one. We mark in 0. We go to -1 in this case. We put our circle there. We're looking for numbers smaller than -1, but we leave the circle open because -1 does not actually work as a number for D. Absolute value inequalities work kind of the same way. I think it makes a little bit more sense if we graph them first before we talk about their answers. So let's go ahead, we put in 0. Let's just think of numbers that when you take the absolute value of them, they're bigger than 1. The absolute value of 2 is bigger than 1. So let's just put like a dot there for a second. The absolute value of 3 is bigger than 1. It's also or equal to 1, it's strictly bigger. That will be true for all the numbers bigger than 1. So we're going this way. Now here's the thing, it's also true for the negative versions of these numbers. The absolute value of -2 is equal to 2, which is bigger than or equal to 1. Absolute value of -3 is going to be bigger than or equal to 1. And we can keep going all the way over here. But what about -1 and 1 in this case? In those cases, they work as well because we have the or equal to. Now, if we look at this the way that we did with our compound inequalities, this one looks like an or compound inequality. We have two distinct sections going towards -infinity and infinity. So our answer to this particular case is going to be -infinity to -1 union 1 to infinity. Now, you'll notice I put the wrong brackets here. We should have a hard bracket because of the or equal to underneath there. All right. Similarly, we have x is smaller than 3. So let's go ahead and just put in 0 in a number line. We'll go to 3. Thinking of numbers smaller than 3 absolute value. So for example, absolute value of 2 is smaller than 3. The absolute value of 1 is smaller than 3. So on and so forth. Absolute value of 0 is. The absolute value of -1 is smaller than 3. Absolute value of -2 is smaller than 3. Now in this case, the largest number that we know about is 3. The smallest number we know about is -3. Those aren't invited to the party, so they will stay open. This looks like an AND inequality. Meaning our answer is going to be from -3 to 3. Those are the only numbers that we know about. If we have to write this as a general rule, greater than means or, and less than means and. So let's go ahead and solve some absolute value inequalities. We have the steps written right here. So first one, let's look here at the absolute value of x plus 4 is bigger than 2. Okay? First, we have to get rid of anything outside the absolute value. Great, there is nothing outside the absolute value. So from here, we're going to split it into two equations, similar to how we solve an absolute value equation. X plus 4 is bigger than 2. We can also split it into another equation. X plus 4 is less than -2. Similar to how we solve an absolute value equation when you have to split it into two, we have to split this into two as well and flip that sign around when you change the sign to a negative. Flip that sign around when you change that sign to a negative. So from here, we subtract 4, giving us x is bigger than -2, and x is, we subtract 4, smaller than -6. So when we go ahead and graph this, we start at 0. We can go over to -2. We're looking for numbers bigger than -2. And we can go over to -6. We're looking for numbers smaller than -6. This looks like an OR inequality. So from here, we can go ahead and write it in interval notation. -infinity to -6. Soft bracket, because there is nowhere equal to. Union with -2 to infinity. Let's go ahead and try another example. We have 2. Absolute value of y is less than or equal to 8. So from here, the first thing we have to do is get rid of anything outside the absolute value, meaning we divide by 2, giving us absolute value of y is less than 4. So we could split that into our two equations. Y is less than 4, and y is greater than -4. So we need all the numbers that are smaller than 4, but bigger than -4. If we were to graph this, it would look something like this. We go over to 4. We have to go over to -4 as well. We're looking for the numbers smaller than 4 and the numbers bigger than -4. Keeping in mind, our answer is the overlapping part. So if we wrote that in interval notation, it would be from -4 to 4 in this case. That will get hard brackets. As always, let me know if you have questions.